Hi, this is Mrs. Rodolphe, and I am going to go over Section 2 Calculator of the Quiz 5 Interim 2 Study Guide. So, you may use your notes and prior knowledge to answer the following review questions, show all work, and explain your reasoning. You may use a calculator. All right, so again, I will go over some of these, and if I don't go over a few of them, they will be in the key, so use the key to check your answers, and also try them on your own first. Pause the video before I go over them, and then just use my video to check your answers. But please try it on your own first, because you're going to have to do it on your own for the test. So number 12, consider the function h, where h of x equals 3x squared minus 2x plus 4. Part A, complete the equation to represent h of x plus 2. Write the numbers on the lines to correctly complete the equation. So for this one, if whatever's inside the parentheses, that's our input. That's what we want to plug into the equation for x. So anything with x, I'm going to substitute x plus 2 into it. So I'm going to rewrite h of x plus 2 equals 3. And again, instead of this x, I'm substituting x plus 2. Squared minus 2, and then there's another x, so I'm going to write x plus 2, and then plus 4. All right, now we can solve the problem. So first I want to do my exponent. Now remember, if it's x plus 2 squared, now be careful with this, because I'll have a lot of students that think, oh, x squared is x squared, 2 squared is 4, they'll think, oh, this is x squared plus 4. That is wrong. If it's x plus 2 squared, I'm going to rewrite it up here. I'm going to use the box method. That's saying x plus 2 times x plus 2. Remember, if it's a squared term, it's being multiplied by itself. So we would do x times x, which is x squared, 2 times x, 2x, x times 2 is also 2x, and then 2 times 2 is 4. Then we would need to combine our middle terms, and those would equal 4x. So notice how if you just distribute the x and the 2, you're just going to get x squared plus 4, but we still have a middle term. So we have to account for that. So we're going to use the box method. So for this one, I would rewrite it as 3 times x squared plus 4x plus 4. And then I still have my minus 2x plus 2, oops, running out of room here, plus 4. All right, then I have to distribute. So the number in front is the 3. I'm going to multiply it by everything inside these parentheses. 3x squared, and then 3 times 4x plus 12x, 3 times 4 plus 12. Then distribute this negative 2 to everything. Negative 2x minus 4, and then the plus 4. All right, then combine your like terms. h of x plus 2 equals this 3x squared. There's no other 3x squared, so I'm going to leave that. 12x, I can combine this with negative 2x, so that's going to be 10x. And then we have plus 12 minus 4 plus 4. So 12 minus 4 is 8, plus 4 is 12, plus 12. So that would be our final answer, 3x squared plus 10x plus 12. Part B, the function f is modeled by the equation f of x equals 4. What are the solutions to function f and function h, where f of x equals g of x? For this one, I am seeing that I made a mistake. This should be h of x, not g of x, because we are talking about the h of x up here. So I will have to revise that. All right, so for h of x to equal f of x, we want to put these equations equal to each other. So I'm going back to the original h of x up here, not what we did for part A. So we want to put these equal to each other. So 3x squared minus 2x plus 4 equals 4. All right, then we would solve for x to find the solution or solutions. It does say what solutions, so I know there's going to be more than one. All right, so this is a quadratic function. It has an x squared term. You get to choose what method you use. So remember, there's factoring, completing the square, and quadratic formula. So I'm first going to get it equal to 0 and see what method I think would be easiest. So I'm going to subtract 4 from both sides. 3x squared minus 2x equals 0. All right, I completely got rid of my c term. This is one of those where if they both have the variable x, I can take that greatest common factor of x out. That would go on the outside of the parentheses. Then I divide. 3x squared divided by x is 3x. Negative 2x divided by x is negative 2. And then I put both my factors equal to 0. Remember, this x over here needs to be equal to 0. So x equals 0 is one of my solutions. Then I need to solve 3x minus 2 equals 0. Add 2 to both sides. And then divide by, oh, I wrote that wrong. 0 plus 2 is 2. And then divide by 3. So my other solution is x equals 2/3. So this quadratic function has two solutions, two x-intercepts at 0 and 2/3. All right, number 13, Tanya's building a rectangular patio in her backyard. The width of the patio will be 0.5 times the length of the patio. Part A, create an equation to represent the area of the patio A in terms of the length L. Write the symbol and expression on the lines to correctly complete the equation. All right, so you need to be familiar with area, which is length times width. In this situation, I know the width of the patio will be 0.5 times the length. So we can plug that in for the W. A equals length times 0.5 times L. All right, so I know that I'm going to multiply the 0.5, so it would be the multiplication symbol here. And then looking at all of my options, it's not just L because I have L times L. L times L is not 2L, that's L plus L. L squared, L times L, that's multiplying by itself. I want to choose the L squared. So it's 0.5 times L squared. So remember, L times L equals L squared. Part B, Tanya decides to make the area of the patio 128 square feet. What are the dimensions in feet of the patio? All right, so this is where we can plug in. So we know from the previous page our formula is A equals 0.5 times L squared. So if I know the area is 128, I'm going to substitute that for A. And then we need to solve for L and W. All right, so then I would divide by 0.5 to both sides. 128 divided, so again, this one's a calculator section, so practice using your calculator. 128 divided by 0.5 would be 256 equals L squared. And then remember, when we have a squared term, the inverse operation is the square root. So we would hit the second button, x squared. So I hit this second and then x squared to get my square root symbol. And then 256, which is 16. So I know my length equals 16. And then going back to the previous page, remember we said the width was 0.5 times the length. So I would then plug in 16 for L and do 0.5 times 16. Half of 16 is 8. So the width would be 8. Number 14, Juanita bought a new computer 3 years ago for $2,100. The value of the computer has decreased exponentially, and is now valued at about $720. So we know 3 years ago, 2100 decreased exponentially. So if we're using the exponential function, again, A is your initial value, starting point. B is the growth factor. What is it being multiplied each time? And then X is the years since that initial value. So if we plug in all of the values to our equation, I know that Y is going to be the value after the 3 years, so that's 720. A, the initial value was 2,100. My growth factor is what I need to figure out, so I'm going to keep that B. And then it said that the computer was bought 3 years ago. So if you plug it into the formula, and then you can solve for B. So first I want to divide, it was multiplication, 2,100 times B cubed. So I'm going to divide both sides by 2,100. We want to keep it as a fraction. So use your fraction mode, the green alpha button, and then press the button to the right. See how all these little green symbols are above the keys? See how there's that little fraction symbol right there? So then I have my fraction on here. I'm going to put 720 over 2100, enter, 12 over 35. So 12 over 35 equals b cubed. All right, and then the inverse of b cubed is the cube root. Also, something to be familiar with, the inverse is also if we multiply or do to the 1/3 power. So you can either do the cube root or you can do 12 over 35 to the 1/3 power, because that's the inverse. Think of the inverse of 3 over 1 is 1/3. So that's something else to be familiar with, but you can, this is the calculator section, so I would just do the cube root. So for cube root, remember we go to math, and then if you see number 4 has that cube root symbol, and then number 5 you could put any root there, it just has X for the root. So I'm going to press 4 to do cube root, and then I would put my fraction 12 over 35. And then it will give us a decimal, which is okay. So we're going to round to the nearest tenth. So 0.69, that 9 rounds up to 0.7. So the growth factor is about 0.7. So then it's telling us to write a function. So I need to rewrite the function as y equals the initial value 2100 times 0.7 to the x power, so that we could find the value after any amount of years. All right, for part B, Juanita predicts the value of the computer will decrease exponentially by 15% over the next 3 years. If Juanita's prediction is correct, about how much will her computer be valued at, that should be a D, to the nearest $100 after 3 years? So we need to solve to the nearest $100 after 3 years. So we are going to use the equation y equals a times b to the x again. And we're going to so her computer is 720. So now we're doing another 3 years after that. So we know the initial value is going to be 720. To find the growth factor here, so she knows it's going to decrease by 15%. So if we're looking at currently it's $720, that's 100% of the value currently. And then she knows it's going to decrease or subtract by 15%. And that would give us 85%. And then what you do is you convert that to a decimal by dividing by 100. So I would do 85 divided by 100. And I would get 0.85. So pretty much you're just moving the decimal 2 to the left to divide by 100. So that would be my growth factor, because only 85% of the value is remaining. So think of it as growth as in what is remaining, And so we would just subtract whatever it is if it's decreasing from 100. If it's increasing, you would add that to 100. And then we want to find it after 3 years. All right, so then you can just plug this into your calculator. If you do it all at once, use the parentheses. So I would do 720 parentheses 0.85, and then that caret symbol here. Remember, that's the caret, and then I can press 3 to have an exponent of 3. So then it's $442.17. It says to round to the nearest $100. So the hundreds place is going to be this 4. So, and then I look at the number to the right, the 4 tells me to stay the same. So the nearest hundreds would be $400. All right, next problem. All right, these are the constructed response practice. Again, do these on your own first and then use my video to check. So go ahead and pause it now and try it on your own. All right, 15, the tables show data for a linear, exponential, and quadratic function. So we have h of x, function k of x, and function g of x. So I'm just going to find the rate of change, or use whatever change that's happening. It may not be a constant rate. I notice with my x values, these are all adding by 1. -3, -2, -1. They all are adding by 1. So I just need to find my change in y to really see what's happening. All right, so remember, first you can try subtracting. So like take the second term and subtract the first term. 10 minus 14 is -4. And then just keep going to see if there's a constant. 6 minus 10, -4. 2 minus 6, -4. So I am seeing that these are all subtracting 4 each time. So when it's subtracting the same amount each time, that's linear. It says, explain how you know which functions models a linear, exponential, and quadratic function. In your explanations, describe how you determined, another typo, h of x, k of x, and g of x when x equals 4. So I also need to complete each table with when x equals 4. So if I know it's subtracting 4 each time, -10 minus 4 is going to give me -14. All right, for b function k of x. So now let's do the same thing and see if we find a pattern. So let's do 12 minus 21, that's -9. 5 minus 12 is -7. 0 minus 5 is -5. -3 minus 0 is -3. -4 minus -3 is -1. And then -3 minus -4 is +1. So here I am seeing a pattern. But if I do the second rate of change, these are all adding by 2. So if the second rate of change, notice I have 2 rows of a rate of change here, that means that this is a quadratic function. Something else that shows me this is, notice how the numbers were decreasing at first, and then after -4, it jumps to -3, which is increasing. So that also shows me that this is going to have that U shape, where first it's decreasing, it's going down here, and then at this minimum value or vertex, it starts going back up. So that's another signifier that this is quadratic, because it's first subtracting, then starts adding. All right, so if we follow that pattern, I'm going to want to add 2 again in my second rate of change. So 1 plus 2 would be +3. -3 plus 3 is 0. So when x equals 4, that would be 0. All right, function g of x. All right, well, now that I've deduced that the a is linear, b is quadratic, this must be exponential. I know that I have to divide with exponential. We could also add, and I'll show you how adding can show you that. So let me just do the adding in case it's like hard for you to see. So 1 minus, let's use our fraction, 1/2 would be, so that's adding 1/2. 2 minus 1, that's adding 1. 4 minus 2 plus 2. 8 minus 4 plus 4. 16 minus 8 plus 8. 32 minus 16 plus 16. So now looking at what it's adding, these numbers are multiplying by 2 each time. So I know this is exponential because they're multiplying by the same number each time. And then to double check that, we could also go and divide. 1 divided by 1/2 is 2. 2 divided by 1 is 2. 4 divided by 2, 2. 16 divided by 8, 2. So you can go back and check that way. All right, so I'm not going to write this all out because I want you to practice, but just to keep in mind when you're answering these constructed responses, make sure you're answering fully and explain. It says explain how you know which functions model each type. So like, I'm just going to explain it verbally right now, but I want you to write it down to practice. But you know, I would say something like, I know function h of x is linear because it's subtracting 4 each time. Or, you know, it's adding -4 at a constant rate. It's, you know, adding or subtracting the same amount each time. And then I would explain how I determined when x equals 4. Well, I went when x equals 3, it was -10, and then I subtracted 4, and I got -14. So just something simple like that. And then for function k of x, when I calculated the rate of change, I saw that the second row or the second rate of change was adding 2 each time, which tells me it's quadratic. Or you can also mention how the numbers were decreasing at first for the y value, and then they started increasing. So that shows that it would be a parabola, first increasing, then decreasing. So those are 2 different ways to explain that. Then I would explain how, since I knew the second rate of change was adding 2, when x equals 3, it was adding 1. I added 2 to that, which would mean it's adding 3 next time. And I did -3 plus 3 equals 0. And then for function g of x, I saw that it was multiplying by 2 each time. So that would make it exponential. And then over here, to find when x equals 4, we would do 32 times 2, and that would equal 64. So make sure you practice writing it out and explaining it on your paper. All right, last constructed response practice. Tarek earns $11 per hour at his job. He deposits everything he earns into his savings account. He currently has $50 in his savings account. Corey earns $8.50 per hour at his job. He deposits everything he earns into his savings account. He currently has $225 in his savings account. Write a system of equations that can be used to determine when Tarek and Corey will have an equal amount of money in their accounts after working the same number of hours. How many hours will it take for Tarek and Corey to have an equal amount of money in their accounts? Show your work. So we first have to write a system of equations, 2 linear equations. Remember, these are y equals mx plus b. So Tarek, he earns $11 per hour. I know that's going to be my slope. X is my hour, so $11 per x hours. And then B is our starting point, and so he started his account with $50. So that's his equation. All right, then my other equation for Corey, he's earning $8.50 per hour, and he started with $225 in a savings account. So these would be our system of equations. So that's our answer to the first bullet point. All right, the second one, how many hours will it take to have an equal amount of money? So then we have to put these equal to each other. 11x plus 50 equals 8.5x plus 225. And then we can solve for x, the amount of hours they would have to work to have the same. So I always start with, when I have variables on both sides, I move my smaller one. So the 8.5x, the inverse would be minus 8.5x. 11 minus 8.5x is 2.5x. plus 50. Those cancel out. We're left with 225. Remember, draw that line down the equal sign if it helps you keep it balanced. All right, then I need to get all my constants to the opposite side of the variable. So instead of plus 50, I'll do minus 50. 2.5x equals 175. Divide by our coefficient, 2.5. X equals 70 hours. So then I would explain how they will both have to work 70 hours to have an equal amount of money in their accounts. All right, thanks for watching the video. Have a great rest of your day. Bye.